This question is about an asteroid coming in and hitting the Earth. It was given a size. I think we're given a diameter. We're given an initial velocity and a density. And then we're asked, how massive is it? So mass is equal to density times volume. I put a big V there. I guess I could just put V, big V for volume, which is not the same as little v for velocity. Or most people would know that density is equal to mass divided by volume. How dense something is how much stuff there is per volume. If you don't have very much stuff per volume, you're not very dense like air. If there's lots of stuff in a certain volume, then it's something like a liquid or a solid. So we know the density. What's the volume? We're assuming this is a sphere, I think. Yeah, assuming a sphere, the volume of a sphere is, you could look it up online, Google or something, volume sphere, it'll be right there. 4/3 pi radius cubed. Don't forget that the radius is equal to half the diameter. So you guys can figure out the volume, so you can plug everything in and figure out the mass. Watch your units. A kilogram is equal to, well, actually, let's make sure. Watch. Let's see. You're gonna have to. Let's be careful of our units. We want mass in kilograms. The size of the diameter is in kilometers. So if this is in, let's say this is 10 kilometers. Well, 10 kilometers would be 10,000 meters. And you'd better make that conversion first before you put it into that cubed. You can't just come up with an answer and then multiply by 10,000, because when this 10,000 is cubed, that cube is going to dramatically multiply this factor of 1,000 here. That'll be then a factor of 1 billion once it's inside the cube. Basically, make sure you have your units converted first, or make sure that you know how to convert cubic units. How much kinetic energy? Kinetic energy is part B. This is part A. This is part B. Kinetic energy is 1/2 mv squared. I would convert the velocity into meters per second too, so you can come up with an answer in joules. A joule is a kilogram meter per second squared. And last, part C, compare this to how much energy humans use. The answer is in the order of centuries, but not many centuries. So every couple of centuries, humans use up about as much energy as it took to wipe out the dinosaurs in one fell swoop, which is actually a long time revealing that the energy carried by massive objects through space is dramatic, but at the same time that humans can, over several centuries generate the same amount of energy. It's sort of like there's a little, given the flux of energy that we push through the Earth, it's sort of like a few percentages, or a few 0.5% or 1/3% of a big asteroid coming in and smashing into the Earth every year. So on one hand, it's a bit humbling knowing that there are things producing far more energy than us, but if you think about it, it doesn't take us that long, and we are pushing as much energy through the Earth as a big asteroid does every time it smashes us.